All right, so here we are. So now you're going to show me how to look at this through the lens of a geometric series.
So this is 1 plus z squared plus z cubed plus z to the fourth. So going from term to term, you add, you multiply by z every time. So if you have like 1 plus something like this, up to, like, say z to the n, you would, that sum would be equal to 1 minus z to the n plus 1 over 1 minus z.
Okay.
So here, in this case, we have up to the fourth power. So our sum would be equal to 1 minus z to the 5 over 1 minus z. But z to the 5 minus 1 is 0, so z to the 5 equals 1. So that means this top part becomes 0. And since z is not equal to 1, if z was equal to 1, this would be 0 over 0. It would be undefined, but since it's not, it's not, bottom part, it's not 0, so that means this is 0. You just get 1 again.
Cool, that's a really nice job. Now, one thing we didn't talk about last night, maybe is a fun extension of this idea here, is that this is also a geometric series. It starts with z to the 15th, and then we multiply it by z every time.
Yeah.
Up to z to the 50th. So can you figure out how to write from the beginning? Use the geometric series rule?
Well, let's see. Well, we could either figure out what this sort of missing part is, z, or 1 plus z squared, up to z to the 14th.
Okay.
And then subtract that from this sum. I guess since the formula starts with 1, we have to do that.
Okay.
So you'd get 1 minus z to the 15th over 1 minus z. And then you'd subtract that minus this, and then be subtracting that from 1 minus z to the 51st over 1 minus z. Again, this simplifies to 1. So this whole term becomes 0. This simplifies to z to the first. 1 minus z over 1 minus z, this term becomes 1. So you get 1.
Nice. Okay. Do you remember another way you looked at this problem last night?
You could look at it through sort of trigonometry using cosine and sines.
Okay, yeah, that's great. Let's take a look at that.